Okay?
Yeah.
All right, well, we're going to start the lab sessions now. Obviously, this isn't quite what we expected. I really hoped. Do you want to show, actually, I'll just walk around like this. Everyone can see this lovely teaching lab. We're in the Cruciform building. You might have used this lab before. Anyway, this used to be University College Hospital, and it's now converted entirely for teaching. You can see the really big spaces, and it seems a bit strange for us to be in here alone. So Jasmine Ono is doing the camera work. Right, so I'm just going to go through and do the protocols, do what you would, what I had hoped that you would be doing. So if we were meeting to do the lab session, you'd have a written protocol like this, incredibly detailed. I will make these available, but you know, it's very hard to follow the steps in a written protocol unless you're actually doing the thing, or if you can see what's going on. So I don't really know the best way to teach this, because this is new for me too, but I think the best thing to do is for you to watch the videos and I will try really hard to kind of explain what I'm doing at each step, and I might be a bit repetitive. Right. All right, let's just start and see how it goes. So our first experiment is about, well, it's called plating, and it's really simple, but what I want you to kind of think about as a more sort of general level is what causes variation in an experiment? What are the sources of error? So the things we'll be looking at we'll be essentially doing replicated experiments. So we'll do this a few times. I'll only record it once though. And you'd all been doing it, each of you would be doing the same experiment each. So we'd have all these replicated experiments. And I want you to think really about why, if you started with the same biological material, this goes back to my kind of overall theme for this course really. How repeatable is evolution? So if you want to do experiments to determine how repeatable is evolution, the cool thing about experimental evolution is you can do the same experiment again and again and again, and then you can see what the variation is in the outcomes. But we also have to consider the kind of technical, what we would call the technical errors. So those are things that might come from pipetting slightly more or less, sampling because you're randomly sampling a population. You might sometimes get a few more or a few less. And then there's other kind of random effects that we get in evolutionary processes, so mutation and so on. So for this first incredibly simple experiment, you all of you, that's me and me doing your experiments for you, a single mixture. I grew up 2 strains, which we can distinguish with genetic markers. I'll give you a bit more of the detail in writing, because that's easier to keep track of. But I've mixed 2 yeast strains together, and I mixed them all really well, and then from that mixture, I've taken samples which are in these tubes. And normally we'd have 16 of these, one for each of you. But these came from the same mixture, right? And there are millions and millions of cells in here, actually about 10 to the 8 cells per milliliter. So we'd expect these are all samples from the same population, and then we're going to dilute these down so that we can count how many cells there are, and we can also count how many of each type. And really what I want you to think about is what causes the variation. We know they all came from the same population. Right, I think let's start with the first dilution. I wonder if we should just stop the video here, because this seemed okay.